In this video, we will build a simple Solidity app, smart contract only using ChatGPT from openAI. So the application that I want to build is a multi-sender application where we send Ethereum to a smart contract, and the smart contract then sends the Ethereum to different addresses that we specify. Yeah, um, and I'm not going to write any line of code. Everything. So the way we get this project is just by telling ChatGPT with text instructions on what I want, and then he will convert these instructions into Solidity code that I will then compile here in Remix. And once it compiles correctly, then I can deploy it. And then at the end of this video, I hope we have a complete working smart contract that we can use in real life. So the way ChatGPT works is similar to DALL-E 2. This is also from OpenAI. On DALL-E 2, you could create images from text description. For example, if you want to create an image like this, you would say astronaut riding on a white horse in space. And yeah, this would be the response. And we can use the same approach using text description here on ChatGPT. So we tell him, hey, write me a smart contract that does X, Y, and Z. And yeah, then we should get a code response, and the code response should ideally work. And the way this works is like this. So we start here by telling him, write a smart contract in Solidity that sends Ethereum to multiple externally owned addresses. Use Solidity version 0.8.0. So he understands what we want, and he starts the code out correctly by specifying the Pragma Solidity version. Then he's creating a contract instance with the name of multisender. Inside of this contract are all these variables, constructors, and functions. What all these functions do, I tell you once we have a working contract. And yeah, he is also giving us some information on how to work this contract and what this contract does. So let's just copy this code here and let's try to compile it in Remix. Make sure when we compile the smart contract, we use the correct compiler version. And yeah, let's click here compile. And it looks very good already. So we get 2 warnings and 1 error message. The first warning message we can ignore. This is the SPDX license identifier. We absolutely don't need to worry about this. This does not affect the performance of our smart contract. Then we have a second warning saying the visibility for constructor is ignored. So we have here some squirrely lines. And we have 1 error. And the first thing that we should do is fix the error message, because when we have an error message, then we cannot compile the smart contract. If we cannot compile the contract, we cannot deploy the contract. We could, if this error message would not be here, then we still were able to actually compile and deploy the smart contract even with those warnings here. So let's fix here the error message. And I'm just going to copy here the error message and tell him to fix it based on the error message. So I copy the error message here and tell him, hey, when compiling the code, I got this error and this warning. So I give him the warning message also right away. So copy this here and paste this here. So let's see what he's doing with this information that we give him. Sometimes he is really quick in making changes and improving right away. Sometimes you can tell him 10 times and he won't fix the mistake. So let's see how he's doing right now. Okay, I already see there's a difference here. So this function is now, the array of addresses is now payable. Okay, this function is also payable. Looks already better. Let's just copy this code here. Remove this one. And let's try to compile it. Okay, perfect. So all of the error messages went away. All we have left are two warnings. Again, the warning identity, so the SPDX license identifier, we don't care. And we have here the visibility for constructor is ignored. And yeah, let's fix this here. Let's see if we can do something about this warning. So I copy this here again. Remove this warning. Theoretically, we should already be able to actually still to deploy the contract and work the contract, but I still want him to at least try once to maybe fix here this warning issue. Okay, now we have an empty constructor. I don't know what's the point of that, but let's copy here the code. So, okay, so we still get the same error. I don't know what purpose this was here. You know, this makes absolutely no sense. What I'm going to do is I try to remove this manually and compile this. Yeah, even though I said I would not, but yeah, you know, before I keep telling him 10 times, I just remove this constructor myself. Error is gone. All we have left is the ISPDX license identifier, and as I said, we don't care about this one. So we have here the account, so we can deploy the smart contract. Make sure you use the correct compiler version over here, and once it compiles, then you can go over here and deploy the smart contract. Make sure you use the correct contract instance. I want to deploy the multi-sender contract, and this matches the contract over here. Then we can click here on transact because we don't have any constructors. So let's do this. Okay, we got a contract, but if this works, I don't know. So address recipient. So I need to add here an recipient. So I copy one address from my notes and transact. Okay, so recipient 0 should be this address. Okay, let's add another recipient here. Transact. Okay, now recipient 1 should be this address. Okay, this works too. Let's add a third recipient. And I add this one as well. And the number 2, so the third recipient should match this address over here. Okay, so this function works. Now what we have to do is send Ether. So I assume that we first have to send Ethereum to this smart contract, but how are we going to do that? So let's just try here to send 30 Ethereum and then click here the send Ether function. Okay, this works. 30 Ethereum were deducted from here. There are no Ethereum in this smart contract. Now, these addresses should now have each 110 Ethereum if everything works correctly. So when I open this, there should be 3 addresses with 110 Ethereum. And yes, it works. So we have here 1 address, 2 address, and these are the addresses that match. As you can see here, 0x0a0, this would be this address. 0x1, this would be address 1. and so on. So this absolutely works. And yeah, it does actually what we told him to do. So we're sending 30 Ethereum to the smart contract, and then the smart contract is dividing the amount of Ethereum to the over to the addresses. Let's try this with a different amount of Ethereum. Let's just go back to this one. Let's send 50 Ethereum, 50 divided, no, let's send 60, this is easier to calculate. 60 now, every one of these addresses should receive 20 Ethereum, meaning when I open this up, those three addresses should hold 130 Ethereum each. See if this works. Okay, looks like this works. Balance is still 0 here. Let's open it up. And perfectly, it works. Now we have 130 Ethereum each. Yeah, this is absolutely mind-blowing what you can do just by simple information like this that we gave him. So all we did basically was just telling him, hey, write a smart contract that sends Ethereum to multiple externally owned addresses. Using this version, we got the version right away. Correct. Then we got a contract. We had two error messages that he fixed for us. And by the time we got the third code solution, we have a working smart contract. This is absolutely mind-blowing, and yeah, it will only get better. It's not, you sometimes, you run into errors when trying to replicate this, but just keep on playing around with it, and you will get at the end of, if the contract is not too complicated or too abstract, you can definitely work with ChatGPT. And even if it's just for learning, so you can also use here a function. We can do reverse this. So I copied here this code. We can start this thread, and all I do is say, hey, explain this code to me. And I paste the code in question. Oops. So this was the code. And hit enter. And now it tells me exactly what this code is doing. So this is a Solidity smart contract for the Ethereum blockchain. The contract is called Multisender. It allows multiple recipients to be added to an array, and for Ether, the native cryptocurrency of Ethereum, to be sent to all of the recipients in the array. The contract has two public functions, add recipient and send Ether. Add recipient function allows addresses to be added to the recipient's array. This is what we have done over here. Whenever we add here addresses to an array, and the send Ether function is used to send Ether to all of the addresses in the recipient's array. And this is what we did over here. Click send Ether. This was, we have to specify the amount of Ethereum that we want to send. So let's send 10 Ethereum. Click send Ether. Then we have to wait for the transaction to be mined. If it mines correctly, okay, I don't know, something is wrong right now. It's stuck or something. And yeah, what else was here? The function first checks if the contract has a sufficient balance to send the amount of Ether specified in the message value variable, and then sends an equal amount of Ether to each address in the recipient's array. So it splits out the send Ethereum evenly across all the addresses in this array. Yeah, and this is how the smart contract works. This is how ChatGPT works. And you can try now on your own to